Hi, I'm Miss Van Loan, and in this video, we're going to complete Module 2, Lesson 3, Independent Practice. Remember, I recommend using your math notebook and using your paper the normal way, which is called portrait. Please use a pencil, either number 2 or mechanical, and have an eraser handy. For the purposes of this video, I will be using a blank sheet of white paper, and it will be in the landscape orientation. That is because it works better for the video camera. I'm also going to be using pen because it shows up better on camera. All right, let's get started. Module 2, Lesson 3, Independent Practice, and put your name. Okay, number 1, simplify. -5 plus 1/4 parentheses 4x plus 12 close parentheses minus 12 plus 5x plus 24. Okay, so let's just deal with this by itself and figure out what that equals, because then I'll be able to see everything as whole numbers without the fraction. So we'll do 1/4 times 4x plus 1/4 times 12. I'm going to rewrite these and put them over whole numbers. So 1/4 times 4x over 1, and this one is 1/4 times 12 over 1. Now, do you remember how to cross cancel? So 4 and 4 will cancel, and those will become 1s. And then this is 1 over 1, which is just 1, times 1x divided by 1, which is just x. So this just equals x. And that makes sense if you think about it, because if you take 1/4 and you multiply it by 4, that is a number times its inverse, which equals 1. So we did a whole lot just to prove that, but that will be x. Okay, on this side, we can cross cancel. 4 becomes 1, and 12 becomes 3. 4 divided by 4 is 1. 12 divided by 4 is 3. So now this is 1 over 1 times 3 over 1, or 1 times 3. So this is just 3. And that makes sense because multiplying by 1/4 is the same as dividing by 4, and 12 divided by 4 is 3. All right, let's bring everything else down. So we have -5 plus that x plus 3 minus 12 plus 5x plus 24. So at this point, we could use the tiles, but I don't think I'm going to. I have them all right here, but I feel like it's going to take a little bit longer. If you want to use the tiles to help you, you absolutely can. I am going to use a highlighter or two. So including the sign in front of the term, I'm highlighting. I include the sign so that I remember if it's positive or negative. So 1x and 5x is going to give me 6x. -5 and +3 will leave me with -2. -12 and +24 will leave me with +12. And then a -2 and a +12 will leave me with 10. So 6x plus 10. Let's do number 2. 3/5 parentheses 5x minus 15y close parentheses minus 3/8 parentheses 16x minus 32y. So let's go ahead and put these guys over 1s. And then write this out again as I distribute these fractions. So 3/5 times 5x over 1, and this is minus 3/5 times 15y over 1, minus 3/8 times 16x over 1, and then right here we have a negative times a negative, so that's going to give us a positive right there, plus 3/8 times 32y's over 1. Now I can look at each one of these sets of fractions that I'm multiplying and do some cross canceling. I'm going to put some parentheses around here so that you can better see what partners here, what I'm multiplying out. So the 5 here will cancel with this 5 and leave a 1 and a 1. So this is 3 over 1 times 1x over 1, which is just going to be 3 times x, or 3x. Here, the 5 is going to cancel and become a 1, and the 15 divided by 5 leaves me with 3. So this is 3 over 1 times 3y over 1. So 3 times 3y, 3 times 3 is 9y. And then I need to bring down this negative sign because that's going to be, okay, let's bring that down. 8 is going to cancel and become a 1. 16 divided by 8 is 2. 3 times 2x, because both of these are 1s, meaning this is just a whole number. 3 times 2 is 6 times x, so 6x plus, and yep, 32 is also divisible by 8, so 8 will cancel, become a 1. 32 divided by 8 is 4. So this is 3 over 1 times 4y over 1. 3 times 4 is 12, times y is 12y. Now I can combine my x's and my y's. 3x minus 6x is negative 3x. Negative 9y and positive 12y is going to leave me with positive 3y. Okay. Let's do number 3. It doesn't look like it's as long, so I can probably fit it here just fine. 4/9 x plus 1/3 x. So I have a fraction of an x plus another fraction of an x. Or another way to think about this is 4 over 9 times x plus 1 over 3 times x. We can do a reverse distribute and actually pull out 1x from both of these and have 4/9 plus 1/3. Are you okay with that? Does that seem weird? If we did an x times this and an x times this and we distributed, then we would have what we have up here, 4/9 x plus 1/3 x. So we just reverse distributed. So now we can just deal with these fractions and add them together. What do we do to add fractions? It has to do with the denominator. We're going to get a common denominator. So let's do that. We'll leave the x out here because we have to distribute and put it back later. But we'll do 4/9 plus 1/3, and we need to change that into a 9. So we'll use the giant 1, and we'll have a 3 over 3. So we'll multiply 1/3 by 3 over 3, and that's going to give us 3/9. So x times 4/9 plus 3/9, and that will be x times, we leave the denominator the same, and we add the numerator. So that's 7. 4 plus 3 is 7. And now we can distribute that x again, and we'll get 7/9 x. Okay, number 4. Three-fourths times 6x minus 1/4 y. We're going to distribute. So 3/4 times 6x over 1. I'm going to use the technique that I used over here. Minus 3/4 times, and that's because this is a negative here. And there's no negative out front, so it's just one negative there. Times 1/4 times y. I could have also said right here 3/4 times 6 over 1 times x. That would work too. I wrote it slightly different in these two cases. But we're going to get the same answer. You could write it either way. Let's do some cross canceling here. The 4 can divide by 2 to become 2. 6 can divide by 2 to become 3. So we have 3 times 3, which is 9, times x. So that's 9x in the numerator, or 9 and then times x. And the 2 is in the denominator. So 9/2 x minus, and there's nothing that can cross cancel here. So 3 times 1 is 3. 4 times 4 is 16 times y. So 9/2 x and 3/16 y is our answer. Let's do number 5. Now we're going to be practicing with decimals. 0.7 times, or in parentheses, 12x plus 5y, close parentheses, plus 3.7x minus 8.1y. So we're going to distribute, and we have 0.7 times 12x plus 0.7 times 5y plus these two numbers here, 3.7x minus 8.1y. Let's deal with this. 0.7 or 0.7 times 12. So I can do a little bit of this in my head. And what I'm going to do in my head is take the 7 and multiply it by the tenths place. I'll get 70. Then I'm going to take 7 and multiply it by the ones place, which is 2. 7 times 2 is 14. When I add 14 and 70, I get 84, and then I need one decimal place. So it's going to be 84, and then I put in a decimal place. So it's 8.4x. All right, I know you're probably thinking, wait, Miss Van Loan, you're doing this in your head, and I don't get it. So to demonstrate what I just did in my head, I'm going to take 0.7 and use a generic rectangle. It's times 12, so I have a 10 in the tenths place and a 2 in the ones place. 7 times 10 is 70. 7 times 2 is 14. Put them together and we get 84. And then I have one decimal place, so I put one decimal place. Okay, if you want to do it the old-fashioned way, You can have 12 times 0.7. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. And then we have 1 decimal place, 1 decimal place. This is a little bit easier to picture in your head if you want to do it mental math. This one, you kind of still have to write it down. But either method is appropriate and useful. All right, let's add this one right here. So try to do this in your head. What is 7 times 5? If you know your multiplication table, 7 times 5 is, okay, it's 35. Now put a decimal in there. All right, it's 3.5. So 35, put a decimal in there, it's 3.5 y. You just did mental math. Okay, let's add these guys. So 3.7x, let me use a highlighter here. We have 3.7x, 8.4x, and then we have negative 8.1y, positive 3.5y. So I'm going to take this and put it right here, 3.7x, and I'll add those together. 4 and 7 is 11. Remember, when we're adding, we line up the decimal places. 8, 9, 10, 11, 12. And then that's how many x's we have, 12.1 x's. Now, the negative is larger than the positive. So I'm going to write this the other way and have 8.1 minus 3.5. And then my answer is going to be negative because the bigger one's negative. I need to borrow, so that becomes a 7. This is 11. 11 minus 5 is 6. Our decimal places are lined up. 7 minus 3 is 4. So this is minus 4.6y. And that's our answer. Remember, you can't combine x's and y's. They are different tiles. So those can't go together. They're different. Number 6. 5.2 parentheses 4x plus 7y close parentheses minus 2.5 parentheses 3x minus 8y close parentheses. We need to distribute. And I'm going to highlight this negative and this negative so that I don't miss those. 5.2 times 4. Ooh, this is a good opportunity to try out some mental math. 5 times 4, okay, it's 20. And then 2 times 4, okay, that is 8. So we're going to have 20.8. So 4 times 5 and 0.2. 4 times 5 is 20. 4 times 0.2 is 0.8. So we'll get 20.8. You could do this the other way. 5.2 times 4. 4 times 2 is 8. 4 times 5 is 20. And then we have 1 decimal place. 20.8x. Can you do it with 5.2 and 7? 5 times 7 is 35. Okay, 2 and 7 is 14. So that would be 1.4. So we'll have 36.4. Let's try it. And so this is kind of my generic rectangle right here, 1.4. So we can do it the old way, to C, 5.2 and 7. 7 times 2 is 14. 7 times 5 is 35, plus 1 is 36, and 1 decimal place. All right, a negative times a positive is a negative. 2.5 times 3. 3 times 2 is 6. 3 times a half is 1.5, so that'll be 7.5. X. I might have gone too fast there with my mental math. Let's do it the old way. 2.5 times 3. 3 times 5 is 15. 3 times 2 is 6, plus 1 is 7. 1 decimal place, 1 decimal place. 2.5 times 8. 8 times 2 is 16. And half of 8 is 4. 16 and 4 is 20. 20y. And then a negative multiplied will be positive. Don't believe me? Let's check it out. 2.5 times 8. 8 times 5 is 40. 8 times 2 is 16. 17, 18, 19, 20. We need 1 decimal place. 20.0 is 20. All right. I know you believe me, but I just wanted to show it and prove it to you because that's what math is. You've got to prove it. So I've got my x's here, 20.8x or 20.8 x's minus 7.5 x's. So we'll just actually line that up, 7.5x. When we're adding or subtracting, we line up the decimals. 8 minus 5 is 3. And then 20 minus 7 is 13. Put the decimal in. So we have 13.3 x's. Now the y's, 36.4 y's plus 20 y's. I'm just going to put in the 0.0 there, so I'm lining up decimals. And we're going to have 4.4, and this will be 56. 36 and 20 is 56.4 y's, and we add those. They're positive. 13.3x plus 56.4 y. Let's do number 7. 14.26x minus 8.923x These are all x's, so we can line them up. We're going to have to put the decimal, line up the decimal. So 8.923, 923, and I need a 0 here so that I have 3 decimals minus 3 decimals. This is looking a little bit squished. So I'm going to move it over here and make it a little bigger. 14.260 x's minus 8.923 x's. 0 minus 3, I need to borrow from the one next to it, so that becomes a 5, and this is 10 minus 3, that's 7. 5 minus 2 is 3. I need to borrow again, so the 4 becomes a 3, and this is 12. 12 minus 9 is 3. Put the decimal in. 13 minus 8 is 5. So I have a total of 5.337 x's. All right, let's do number 8. Which property is shown here? Which property? Another one of those. And then we've got 4 times x minus 5, parentheses, close parentheses, equals 4x minus 20. And it looks like we distributed. So let's draw the arrows on there and show that this is 4 times x minus 4 times 5 to equal 4x minus 20. So now we're showing that we see what's going on here, and then we can say distributive. If we just write distributive and we don't show how we know that, then it looks like we just copied it from the answer key. Number 9, let's see if I can squish it in here. The definition of an algebraic expression is, the definition of an algebraic expression is so the definition of an algebraic expression. What is an algebraic expression? It is a set of numbers and variables that have operators. Operators are multiply, divide, add, subtract, and they are written together without an equal sign. Okay? So I like to say that when you don't have the equal sign, it's kind of like not having a period at the end of your sentence. It's not a complete sentence, it's just a phrase. So an expression equals a phrase or fragment. That would be an F, fragment, right? Like a sentence fragment, whereas an equation is like a sentence and it has the equal sign. So the expression has no equal sign and it has a bunch of numbers and variables being added, multiplied, divided, or subtracted. So I would prefer you write that in your own words and not copy it from the answer key, because I feel like it's kind of confusing to copy the exact definition. It's better to put it in your own words. So that's what I'm going to do. I'm going to put it in my own words. The definition of an algebraic expression is a group of numbers and variables being added, subtracted, multiplied, divided, etc. There is no equal sign. It's like a phrase or fragment. Okay, we need to do number 10, so I need a new piece of paper. The definition of a like term is, so I think the best way to talk about like terms is thinking about it in terms of tiles. So we've got these algebra tiles here, which make it really obvious that these guys are different. You can't just combine these together and say like, oh, these are equal, I'm gonna add these together. It's really obvious that they're different. Same thing if we have some other variables in here. So, and if we start putting in some x squareds, these are x squareds, it's like x times x, which is x squared. It's also a square. Like I said, I love algebra tiles. So I would normally have you guys talk about a like term as it refers to tiles and say they are tiles that look the same and can be grouped together. But this class kind of skips through that because we're in summer and we're just going really fast. So we're gonna have to talk about it in a different way, but I want you to still think about the tiles. So the definition of a like term is a number or variable that is similar and can be grouped together. Okay, so this kind of covers both ideas about how the tiles look different and they can't be combined. For example, you can't put these together and say, I have 2 of these. Well, 2 of what? You have to say, no, I have 1x and 1x squared. So you can't put them together. So I think that covers that kind of idea. It also kind of covers the idea that if you have an x and a y in your equation, or in your expression, you cannot put them together. They're different. So it kind of covers both. Okay, and it's a simple enough definition that it's not copying it from the answer key, and I think that everybody can understand that quite easily. All right, I hope that this was a helpful lesson, and please let me know if you have any questions. Thank you.